Sorry guys about that interruption, but if I think about that, the numbers that multiply negative 10 would either be negative 2 and positive 5, negative 5 and positive 2, negative 10 and positive 1, or negative 1 and positive 10. Now, if you think of having a combination of negative 1, I'm going to put a negative 2 here because 3 times negative 2 would be equivalent to negative 6. And then if I add 5, negative 6a plus 5a would result in that negative 1. So now I have two answers for a. I put 3a plus 5 equals 0, and I put a minus 2 equals 0. Now when we end up solving this, what you're going to know, here you're going to get a is 2, and here you're going to get a is negative 5/3. And because a is a length, we can eliminate the negative solution. So we know now that the only solution we have for a is a positive 2. All right? That was a little memory from our algebra factoring. So that is our solution there. Okay, guys, let's take a look at our next problem here. And under this, it's the same type of concept. Just make sure I have it up, right? Now, the same thing, we have two tangent segments. And when we have two tangent segments, I know that they are equivalent and they're congruent because they meet at the same exterior point. So what I need to do now is set both of the lengths of those tangent segments equivalent to each other. Now again, you'll notice it's a quadratic, and when we have it as a quadratic, we need to bring everything to one side. And I subtract 9c, which is nice in this case because both 9c's cancel, and I subtract the 14. So then what I'm getting, 6 minus 14, which would be negative 8, and that would be equivalent to 0. By that happening, by subtracting the 14 and subtracting the 9c, the 9c's cancel, and I actually don't have to factor anymore. I can actually add the 8 back and divide by 2, and then I get c squared is equivalent to 4. Now c would then be positive and negative 2. However, again, since we're dealing with length, if I plugged a negative 2 in here, I get negative 18 plus 14, which will result in a negative answer. So the negative could not be the answer. So if I had c as negative 2 and c as 2, the negative could not be the answer, and our solution would have to be c is equivalent to positive 2. All right? Again, remembering those algebra skills. All right, guys, so now our next one's a little different because we have what we call a tangent segment and a secant segment. But if we take a look at this r represents our radius. If a radius intersects a tangent circle, we learn that they would intersect at a right angle. So that would be a right angle right there. So we're actually looking at a right triangle. So if I wanted to set this up, what I would say is I would use the Pythagorean theorem of r squared plus 9 squared would be equivalent to the hypotenuse square. But what is that length of the hypotenuse? Well, the hypotenuse length would be 3 plus r squared. So this now actually has to be distributed because remember, when we have a binomial squared, it's really 3 plus r times 3 plus r. So we're going to need to FOIL this side out to find the actual values. So in this case, I have r squared plus 81. It's going to be equal to, if I FOIL this, 3 times 3 is 9. 3 times r is 3r. r times 3 is 3r, so that would be a 6r. Then r times r again would be r squared. Now we can bring, if we look at this, if we subtract r squared from both sides, the r squared would cancel out. So you'd actually be left with 81 equals 9 plus 6r. And now I can subtract a 9 to get 72 is equivalent to 6r. And if I divide by that value of 6, r is going to be 12. And that's how we can find the radius of our circle. All right? All right, guys. Now we're into kind of the next section here. We have 10, 11, 12, and 13 are referring to this diagram right here. And what we really want to do is we really want to find out as much information as we can about this diagram in order to help us answer the questions. So right away, they gave me that this angle here is 100. Well, this is circle P. That means KPL would be a central angle. And what we've learned is a central angle is equivalent to the measure of its intercepted arc. So if I look at that, the measure of arc KL will also be 100. All right, now it says LM. Now that might get a little more difficult, but what we need to recognize here is that we were given a diameter. And when we're given a diameter breaks the circle into two semicircles. So I know that this purple arc would have to be 180 degrees. Therefore, if this is 120 and this whole arc is 180, I know that the LM would have to be 60 degrees. Now, if we look at that, if we know this is 60 and this is 100, if they ask me for KM, which we know it's KM this way because if it's two letters, it represents the minor arc, not the major, so it has to be less than 180 degrees. So if I go K to M, I'm doing 100 plus 60, which would be equivalent to 160 degrees. Now the last thing that we're looking at is KN. Now if that, again, LN is a diameter. So therefore I know that this is a semicircle too. So if I'm looking to look at KN, I have 100 here. KN would have to equal 80. So that would be a semicircle of 180 degrees. All right, guys? All right, now let's go down a little more we have 14 and 15 here. All right, now this one they want us to define the measure of arc AB. So we just want to look at some information that we know. Now, if they want arc AB, the one thing we want to know is we were told that these two chords are congruent. If two chords are congruent, that means they intercept the same arc, the measurement of the same arc. So that means see how this is 61? If that central angle is 61, ED would have to be 61. But because the segments and the arc are congruent, the arcs also have to be congruent. Congruent chords have congruent intercepting arcs. Therefore, the measure of AB would also be 61 degrees. Now, same thing, I've had AB here. If A, in this case, if you have a segment that is a perpendicular bisector of a chord, this segment has to be a diameter. If a chord is the perpendicular bisector of another chord, it has to be a diameter. And we also know if a diameter is the perpendicular bisector of a chord, it also bisects the arc, meaning that as this is 65 degrees, my arc AB would also have to be 65 degrees. Therefore, the answer would be 65. Okay? All right, guys, let's go to our next page here. Okay, let me make sure we see. Okay, we see the numbers. 16. All right, let's take a look at 16. I forgot some markings. They had that these two distances were equivalent. I forgot to put it in there. And we know that if you have this C as the center, if C is equidistant from two chords, then the two chords are equivalent. So there again, they're asking for arc AB. If the two chords are congruent, then their intercepted arcs are congruent. So if arc ED is 91 degrees, arc AB must also be 91 degrees because they're intercepted by congruent chords. So that means this is also 91 degrees. Now when we look at 17, 17 is an inscribed angle. We know it's an inscribed angle because its vertex is on the circle. So therefore, its angle measurement will always be 1/2 its intercepted arc. Well, if I look at its intercepted arc, this is its intercepted arc right here, YZ. So that means C would equal 1/2 the measure of YZ, which is 56. Therefore, C will be, oh, I'm sorry, I moved that, 28 degrees. Same logic here. BAC is an inscribed angle because its vertex is on the circle. Therefore, it is 1/2 the measure of its intersected arc. So in this case, it's slightly different. They wanted me to find x. Well, that means 40 would equal 1/2 of x. So therefore, x would have to be 80 degrees. Now, if we look at 19, we want to look at the inscribed quadrilateral theorem. Now, this inscribed quadrilateral theorem states that if a quadrilateral is inscribed, meaning inside a circle where its vertexes are on the circle, that then, if that's the case, then its opposite angles are supplementary. So if I take a look at this, I would know that 4r plus 100, since they were opposite angles, would have to add up to 180 degrees. In addition, q plus 80 would have to add up to 180 degrees. So if I solve this, I'd get 4r equals 80. R would be equivalent to 20. Here, I would subtract, and q would be equivalent to 100. All right. Now, these are review problems for our quiz tomorrow. If you have any additional questions on the homework, I posted all the answers, or the answers were in the back of your textbook, please come to my office hours that are posted on Canvas, and we can discuss any additional questions to prepare you for the quiz tomorrow. In addition, you must also go on to Delta Math and complete the 3-question quiz for your attendance today. Hope to see you at office hours. Thanks, guys. Have a good day.